To think, act, and feel your best, your brain needs constant access to high quality energy. Is it possible that creatine can help our brains to regenerate this energy? And can this combat foggy thinking, fatigue, worse cognitive performance, dementia, and even the deficits that come from having not enough sleep? In this conversation, we're breaking down the powerful new science showing how creatine can influence brain energetics. We're going to talk about mechanisms and the latest clinical research. I'm Dr. Austin Perlmutter, and if you love science, and especially if you love brain science, be sure to subscribe for more content. One other point, this is purely for education purposes. You should talk to your healthcare practitioner before taking any supplement. Let's start with a quick background on brain energetics and why this matters so much. The brain is relatively small in our bodies, but despite that size, it consumes around 20% of our body's energy, primarily in the form of glucose, which the brain imports through the blood-brain barrier from the bloodstream. Glucose is metabolized through glycolysis and through the citric acid cycle, which generates ATP or adenosine triphosphate, which powers our neurons. Additionally, the brain can use ketone bodies as an alternative energy source. Particularly, it does this during periods of low glucose availability, the best example being fasting. Dysregulation of brain metabolism is implicated in various neurological conditions, but especially Alzheimer's disease, where impaired glucose metabolism and the associated mitochondrial dysfunction are thought to play significant roles in disease pathophysiology. We'll come back to this later in this conversation. Let's talk now about creatine. What is creatine and where does it come from? Before we get into the technical aspects of creatine, let's start with the basics. Creatine is a compound made naturally in our bodies out of three amino acids, arginine, glycine, and methionine. This synthesis mainly occurs in the liver and in the brain. Creatine can also be found naturally occurring in certain foods. In particular, these are animal foods. And it's notable that because of this, when compared to omnivores, there's some data showing that vegans consume substantially less dietary creatine and that vegetarians may have lower levels of circulating and muscle creatine compared again to omnivores. Importantly, over 90% of the creatine in our body is located in our skeletal muscle. So a relatively small percentage of total body creatine is actually located in the brain. Now let's shift to talking about creatine supplementation. There are over 1,000 peer-reviewed papers on this topic, and specifically, we talk mainly about creatine monohydrate. So there are many different forms of creatine. You can find these in different stores and on the internet, but the majority of the data for efficacy and use comes from creatine monohydrate. Creatine monohydrate is highly popular in athletes. It has been highly popular in athletes for many decades now. It's been extensively studied. It's been deemed to be relatively safe at doses up to 30 grams a day for up to 5 years in healthy people. And if you're interested in my sources, you can get all of this on my website on this blog. There are some reports when it comes to creatine supplementation of GI issues, of muscle cramps, problems with heat tolerance. But while these topics are still under investigation, there was a recent report that I will draw our attention to. It's a review entitled Common Questions and Misconceptions About Creatine Supplementation. What does the scientific evidence really show? And it looked at some of the popular misconceptions, and it found that in healthy individuals, there's really not much data around some of the most popular misconceptions, including hair loss, kidney issues, muscle cramping, or that women may benefit less than men from creatine supplementation. They also said in this paper that oral creatine monohydrate is likely the best overall form, and they recommended around 3 to 5 grams a day in terms of what the research most strongly suggests is associated with benefit. Now let's shift and talk about the brain energetic mechanisms of creatine. Now, this is so interesting because one of the core pathways that we understand in terms of the mechanism of what creatine does directly relates to energetic. When we consider creatine in the context of exercise, as well as brain health, it is really about a specific reaction. It is a bidirectional reaction where phosphate groups are added to creatine to allow for the regeneration of ATP, adenosine triphosphate. Here's how it works. Creatine can have a phosphate molecule added to it using an enzyme called creatine kinase. This creates a new molecule called phosphocreatine, which can then regenerate ATP from ADP, that's adenosine diphosphate, in places of high energy use. Specifically, we're talking here about in the muscle and in the brain. How does creatine get taken out of the body? Well, it's degraded into creatinine, and this is a molecule that can be excreted through urine. How does creatine get into the brain? There are several transporters, including the creatine transporter 1 or CT1 transporter, as well as a sodium chloride protein that allows for dietary creatine, as well as creatine that is made in our livers, to pass through the blood-brain barrier. The CT1, again, the creatine transporter 1 pathway, seems to be the more important pathway in terms of getting creatine into the brain. Some important research suggests, however, that CT1 may be downregulated, meaning these receptors may be downregulated in the context of high consumption of supplementary creatine. Now, this is important because it may mean that we'd have to take higher levels of supplementary creatine to get the same potential brain-specific effects. So this has been proposed by certain researchers as a potential limit for supplementary creatine in terms of brain-specific benefits. There are some studies now looking at ways to bypass this resistance. For example, you could use a precursor molecule to creatine called guanidinoacetic acid, or there's an analog of creatine called cyclocreatine. Both of these are ways that we may be able to get precursors or variants of creatine in the brain that would bypass this potential resistance. Now let's talk about how creatine may be linked to benefits to brain energy acutely. And I'll be clear, this is where the majority of the research has indicated that creatine may boost brain energetics. So important to understand, as I'm sure you're aware, in the context of a typical day, the brain has ups and downs in terms of energetics, and this is coupled to various stressors. Some of the best studied stressors that are linked to changes in brain energetics include cognitive fatigue, lower oxygen, as well as sleep deprivation. These are both a reflection of brain energetics and influence brain energetics. And this is where creatine may have a especially important role. In a 2015 clinical study, young people who were deprived of oxygen, so not to the level at which they had any significant health risk, but had a decreased exposure to oxygen in their environment, they showed that people who took creatine had improvements in cognition compared to those who were simply exposed to lower oxygen and did not get creatine. An additional 2002 study looked at 8 grams of daily creatine supplementation, and they found that this was associated with a reduction in mental fatigue during math calculations. Another smaller study that was conducted on rugby players in 2011 found that creatine supplementation decreased sleep-related declines in performance. And a brand new study that just came out in 2024 in the Journal of Nature Scientific Reports found that creatine supplementation improved cognitive performance and altered brain energetic signals in healthy people who were sleep deprived. Let me consolidate all this. We know that in certain cases, for example, sleep deprivation, significant cognitive strain, and other kind of high strain situations, our brains may have less access to fuel because they're using up more energy. Creatine, at least in some data, is suggested to act on these pathways. So it's incredibly interesting in that certain cases and certain people may benefit from creatine supplementation as a way to regenerate energy that is lost in the context of some of these specific instances. Let's now talk about creatine for chronic brain energetic issues. So thinking about brain energy in the context of things that happen over years and decades, many chronic brain issues are linked to impairment in these brain energetics. The best example here is Alzheimer's disease. Alzheimer's disease is the most common form of dementia. It affects almost 60 million people around the world and up to 1 in 3 people over the age of 85. So this is a big issue that affects many, many people. Alzheimer's disease is sometimes called type 3 diabetes, specifically because it is linked to impairments in brain energetics. And the data show that there is a decrease in the brain's ability to use glucose. This has been called cerebral hypometabolism in the context of Alzheimer's, and that this cerebral hypometabolism, again, this impairment in healthy brain energetics, is an indicator of Alzheimer's disease and appears to drive disease progression in Alzheimer's disease. Beyond Alzheimer's disease, there is data showing that as we age, we tend to experience a decrease in the brain's ability to utilize glucose. So with this in mind, how does creatine factor into the conversation? When we look at research around Alzheimer's or age-related cognitive decline and creatine supplementation, I will say this is very early research and it's almost exclusively preclinical research, meaning it has been conducted on animals, it has been conducted in cell studies, but it has not necessarily been evaluated to the extent necessary in humans. But there is some initial data and some signals that are incredibly interesting. I'll pull your attention here to a paper that was published in 2023. It was entitled Creatine as a Therapeutic Target in Alzheimer's Disease. And in this paper, the authors talk about the existing lack of clinical data, but say creatine may serve as a potential target for prevention and therapy, and creatine monohydrate supplementation may be beneficial in Alzheimer's disease. They also advocate for more clinical data, which is certainly what we need here. And the good news is that there are some studies that are being conducted right now that are looking into this, whether creatine supplementation may benefit cognition. And I'll draw your attention to a protocol, which I'll put into this article, that is looking at whether that may specifically work on that topic. Okay, how do we put all of this together? So to recap what we've discussed, creatine is a naturally occurring compound found in our food, synthesized in our bodies under normal conditions. Creatine's mechanism of action is, in essence, energy regeneration, and this appears to have significant potential implications for muscle and now for the brain. While the research is still early, some insights suggest that creatine may help to offset certain states of energetic depletion in our brains, more so acutely, with some suggestion of long-term benefit. If you're interested to learn more about the science of creatine and creatine supplementation, be sure to check out all my other content on this subject. In addition, you'll always find the most up-to-date content on my channels by subscribing to this channel and to my newsletter. Thank you so much for being brain curious, and I look forward to speaking with you again soon. Until next time, I'm Dr. Austin Perlmutter, and I'll talk to you later.